Hi, now we will see how can we test API routes of checkbox IO server-side application by automatically generating test cases. To begin with, let us look at the application flow before diving deeper into each part. After cloning the repo, change into checkbox test generation, run npm install to install all the dependencies which are required by Node. Once we have installed all the dependencies, the next step is to create all the test cases by running node main.js. Node main.js will create test.js file, which as you can see right now is empty, with all the test cases that we will use to test our application and the API routes. So on running node main.js, we should be able to see a test file generated with all the test cases, as you can see on your left. Now this is based on the API routes and the logic that we use while traversing using Esprima. Once we have all the test cases to run the coverage, we can use Istanbul. Now this will generate a coverage for each of the files that we are using. Now in this case, we're using admin.js, study.js, and create.js. So we can go ahead to the browser and look at the coverage of each of the files. This would be for study.js, and then we have admin.js and also create.js. So you can see we have around 100% function coverage and 78.5% branch coverage. Now let us dive deeper into see how the architecture of our application uh, is created. In the original application, we have a routes folder which has all the functions that take care of different methods. We have a servers folder which does the routing. So when our application is running, the server gets the request, whether they get request or the post request. It takes care of the URL and then reroutes to the respective class and the method. In our case, to handle the request, we have created a folder called mock routes. Now this folder is similar to routes, except that we have mocked the database, and instead of connecting to MongoDB, this will connect to our mock database. To look at an example, let us see how admin.js looks like. Admin.js has a MongoDB library and a DB which connects to that MongoDB client, and then we use a DB to call database, different methods of the database like collection, aggregate, find one. In our case, we have a mock DB inside mock DB directory by the name db.js. Now this function, it takes care of connecting to a mock data. All the method calls are through this db variable, which is an instance of db.js function. Now this function reads the request and checks whether this is for a study collection or a votes collection or a survey collection. Then it transfers it to the respective collections methods and then runs the respective command. For this purpose, we have mocked test data in test data directory. We have a sample studies.json, sample surveys, and a sample votes data for each of the collection for the mock team. Now we can look at one of the examples. So when a request comes to a server.js, it goes to study. So suppose at the first request, we get a get request at load 1. It goes to study.load study. In our case, the study would route to a mock routes study.js file. So we go to a mock routes study.js file, and then we go to a load study function. which is the direct and the exact replica of routes study.js. Now to create the test cases, we enter the function through main.js, which is our main point of entry. This accepts four inputs. The very first file is the name of the file, which is the routing file, and with the help of which we find out which methods to call and which tests to generate. The rest of the files are the files for which we need to find out the coverage for based on the routes that are present in the servers.js file. Now we have a constraints file which traverses through each of the route files, and then a generate test cases file which generates the test cases based on the return from the constraint method. Now let us look at the constraint method. This constraint method is based on a constraint class which has three instances, three variables. One would be the route path, which is the URL that we are requesting. Another is the kind, which is the kind of the request, whether it's a get or a post, and then the body of the request, if it's a post request. So we start with the first node, and then we try to see for server.js whether this is a get request or a post request. If it's a call expression and if it's a get or a post, we enter that one particular node of interest. Now, first we look at the get request. If it's a get request, then we try to find out if there is a variable that we need to replace, which has a colon in it. If there is a colon variable which we need to replace, then we generate a random value for that colon variable based on our knowledge of the mocked data in the JSON file, and then we push that as a new test case. Similarly, in case of post values, we try to find out different cases. As in the very first case of post, we see that we have a markdown function being called. So when we see that there is a markdown function being called, we generate a random markdown and put that as a body of the post request. Now for the rest of the post request, the other different variations could be that there is a method being called in the second position of the post request or in the third position of the post request. So to handle that, we have a member expression either in the second position or in the third position. The We see that in the second position or in the third position, when we call any method, the first name is the name of the file, which is basically the route that handles it. So we find out the file name based on that route, which is the first object name, and then the method name is after the dot of the second or the third parameter. Then we find out what would be the body of of that particular post request. So we send it the particular file and the particular method. Now let us try to go into the body. Inside the body, we then go into one particular file and then traverse it. So we see if it's either an expression statement and an assignment expression in which we have the left property name as a method name. What that means is once we enter admin.js, this is an expression statement. And if its left method name is the same as the method name that we called it, then we enter this one particular method. After entering it, we find out if there is a variable declarator statement, and if the property name is the body, then we add that property into our request body. What that means is that once we enter it, now suppose we enter open study, we see that the first variable declarator has a request which has a body as its parameter, and whatever is the third parameter, which is the token. So the request uh, is expecting token in the body as a parameter. So we add token as a parameter. It could either be the first one, or we could have a call expression just like a JSON dot string, which could have uh, the third parameter as a body. So we to handle that we write a, a call expression which could have the arguments object type as member expression, and then have a property called body. So this will handle both the cases. Once we enter that method, we see if there is an if statement with the same method name. If there is an if statement with the same method name with the binary expression, then we use those values on the right hand side as the probable values that we could use for our chosen parameters. For example, once we enter notify participant in the admins, it'll have two parameters in the request, email and kind, and we'll go through each of the if requests, and we'll see whatever the value on the right hand side is. We will assign that value to that one particular parameter and then create a test case accordingly. Now, there are cases when we do not have any value assigned for one parameter, just like email does not have any value assigned if we traverse this function. So in that case, what we'll do is we'll just go into the DB and find the probable distinct values that are there in the DB, and then create a Cartesian product of the two, and then create the test cases accordingly. So the value returned from find body would be a dictionary with the key that is the parameter names, and a value which is a list of the probable values of that parameter. If one of them does not have any value, we go into the DB and then we find out the probable values. We find out the Cartesian product of each of them so as to create a test case, and then we push that into a route constraints variable, which we return to a main function. The main function uses that output and creates and generates tests based on generate test cases file, which just parses the return variable and then creates the test cases accordingly. To demonstrate this, we can see that we have invite code as a test research now. So we are considering all the cases where it's a binary expression. Then to cover both the branches, we either put the value of the parameter equal to the value on the right hand side, or one that is not equal to the value on the right hand side. So for an example, if we look at study create method of post, so we can look at the create post. We have invite code as test. If we change this to research, we should be able to see the change here on running node main.js again. On running this, we see that the research has been a test research has been changed to a test research now. Similarly, for the other test cases, it is either based on the values we find out while traversing, or if that is not the case, based on our knowledge of our database and the values returned from the database, that we make the test cases. As you can see, we have a lot more test cases now because after running the first command, which included uploading and posting a few of the values in the database has grown. So the number of test cases have also grown based on different values, different new values that are there now in the database. After this, we just run the similar Istanbul command that we covered at the starting and see the reports for each of them. That's it for the demo. Thank you.